and welcome back. I hope the work we've done so far has helped you think a bit more about how much data there is in your world and how to think about what data you need and how to use it. One thing that may have occurred to you is that unless we measure every single thing in a sample set, every apple in a box, every fish in a pen, every person who buys or doesn't buy our yogurt, we set ourselves the challenge of working out how to get the most information from what is ultimately a limited data set. This is by far and away the usual scenario. There's usually no way you can measure everything, and there's usually no need to. And this is especially true if the measurement is a destructive process, like measuring the flesh colour of fish or the sugar content of grapes. Probably unsurprisingly, there are a number of parameters that will help us understand the nature and usefulness of a given data set. The key ones for us to consider today are precision, accuracy, variability, and validity. Let's take a look at each of these. When we talk of a data set's precision, we're asking ourselves to assess how consistent we are at measuring whatever it is that we are measuring. Another way of asking this is, if we measured the same thing many times, by how much would our measurements vary? By way of example, imagine we are measuring the weight of individual apples in a sample. We could do this by putting each on a scale that weighs to plus or minus 1 gram. We could assume that if we weighed one apple many times, we would get measurements within a gram or so of each other. We would say we had a fairly precise measuring system. However, if we were to try a number of times to measure the weight of an apple by picking it up and estimating its weight from how it feels, I reckon our answers would vary a lot. We would say we did not have a precise measuring system. The more precise is our ability to measure something, the more information we'll be able to take from our analyses, and that's important. Another of these parameters is accuracy. This is a measure of how close our data are to the actual result. Let's think back to the apple on the scales. The scales may be precise, getting the measurements to within a gram or so each time, but the scales themselves may not be properly adjusted. They may be out by 10 grams. So, not very accurate. But this can be okay, as long as we know how accurate we are being. Now next we want to know about the natural variability of the stuff we're measuring. For example, are the apples all within 10 grams of each other? Not very variable for apples that are in the order of 150 grams each. Or are the weights all over the place, ranging between 50 grams and 200 grams? The degree of natural variability within a group has a big effect on what information we can get from a data set. Generally, the more variable a data set is, for reasons of natural variability or our measurement precision, as mentioned earlier, the larger that data set needs to be to glean useful information from it. We'll come back to this idea in later sessions. Now, the final parameter we mentioned is validity. Are we measuring what we want to measure? This might sound silly, but often we can't directly measure the thing we want to measure. For example, we may be trying to measure how much people like our new yogurt. But if we ask the wrong question, say, would you buy this yogurt again? The data we generate, while probably being accurate and with low variability, may be more related to the yogurt's price rather than the taste. So all that shines a light on another level of complexity in our quest for data-driven insight. And it will take a bit of thinking to get straight. I recommend you do some reading around these ideas to help, and be aware that different folk use different words for these parameters. I'm sorry. Anyway, next time we'll start looking at some of the early analysis we can do on a data set. I'll see you then.